Scientists tell us that human beings evolved in Africa, and that these human beings carried in their skin and other organs of the body a brown chemical called melanin. Melanin in the skin protected early human beings from the damaging ultraviolet rays of the African sun. For more than 100,000 years, the black face was the only face on the planet Earth. For more than 100,000 years, these melanized human beings shaped the human personality. But protecting early and modern human beings from the cancer-causing rays of the sun is only one of the functions that melanin serves. For the next 3 Sundays on For the People, we'll examine this complex molecule, which is the chemical key to life, the chemical key to knowledge. Our guest is Mr. Carroll Barnes, an organic chemist who, for the last 14 years, has done polymer or plastic and rubber research in the chemical industry. Mr. Barnes has been a melanin researcher for the last 7 years.
Melanin, for the common person, we normally recognize it as the pigment that we find in our skin, in our hair, in our eyes. And that's about all that we see of it. And we basically look at it as just there as being a cosmetic thing. So the layperson really looks at melanin as just a colorant, a pigmentation. But when the scientists look at it, it's a very, very involved, very highly complex, very functional system.
What role did melanin play in the early stages of human development?
Well, if you look at this thing from the known things that are set, scientific facts that are set today, you think of man evolving out of Central Africa. You think of man evolving near the equator, where there's high intensity of heat, lots of free radicals produced, things of that sort. So nature had to come up with a system that would be universal, something that would look at one particular parameter that was detrimental to man existence, and that is heat. Now, how do you protect an individual from heat? And just one aspect of this whole thing is the ability of this polymer to absorb energy. Okay, so it was a protectant as far as all of the harmful energies that was created outside the body, or they were exposed to outside the body. Internally, as man evolved, he was exposed to many bacteria, many viruses, many diseases. And therefore, you would need something that could counteract those things and help this particular species to survive, to perpetuate itself. And you see many chemical and physical properties of melanin that really points toward that particular thing. It's a system, it's a drug, it's a medicine in itself that helps to heal wounds and things of that sort. So in the early development of man, as far as a protection device from external environment as well as internal environment, and then providing the necessary mental, brain power, the mental capabilities to create and build things around him to help with his survival. So you're looking at a chemical and physical viewpoint. You're looking at it from a psychological viewpoint for developing things, and also a state of calmness, a state of being civilized.
Okay.
Melanin comes into the picture.
Okay, would you explain how melanin could protect early human beings from the sun?
First of all, melanin is what scientists call a high energy absorber, or a free radical absorber. Free radicals are energy particles that are searching for things to react with. Most of the time they're higher energy. And the best way that I can demonstrate that is to talk about radiation. There are different types of radiation, different types of energy that's not neutral, that's looking for things to react with. Well, the way that it protects you is that the chemical mechanism, the chemical functional groups that this polymer is composed of actually will reach out and grab that energy and neutralize it and make that energy a part of the whole structure. And then in turn, use that energy for something that's necessary in the body. So what you have in essence is you've taken something that was harmful, whether it's exterior or interior, and you've changed the energy in form so it can be used as an asset for the system.
Okay, so when the rays hits that skin, melanin-coated skin, what does that melanin do with those rays? Does it scatter it, or what happens?
Well, if you want to just speak of UV light,
okay,
regular ultraviolet. Ultraviolet light, and we get
now,
that.
I told you before we started this that I'm going to be stopping you quite a bit to define and redefine technical terms.
Right.
Most people probably would say that we shouldn't be doing this kind of technical program, but I'm going to stretch, and I'm going to try to insist that our viewing audience stretch just a little bit.
Right.
But go ahead.
Okay, let's take ultraviolet light. It's a component of sunlight, and it's the thing that most people think of or know about when people talk about sunburns, when people talk about aging. Now, the black skin is composed of a chemical that is black because it's highly efficient. This black chemical is melanin. This particular chemical will pick up harmful ultraviolet radiation, whether it's UVA, UVB, or UVC. Now, ultraviolet is divided into 3 different regions. The UVB is the most harmful. And it actually picks up this energy, and through various, what we call, well, the correct name for it is resonance. But what it actually does is homogenize the energy across the entire structure, and then sometimes share that energy with molecules of melanin that's adjacent to the one that picked it up. So you have a dispersion of energy across the molecule as well as across your entire body.
Which does what, in effect? The end result being?
The end result is that this energy, which is normally harmful, is captured, changed in form, and then gradually used in the body or gradually dissipated in a manner that the body could handle it. Otherwise, the DNA that's in the cell would be ripped apart, and the DNA would drain out, and therefore you would have degradation, aging of the skin.
Okay, well, let me step back for a minute and let you, in your own way, talk about melanin.
Okay, well, first of all, melanin is a very, very complex issue. It encompasses all professions. I'm an organic chemist. Professional people like electrical engineers, mechanical engineers, chemical engineers, lawyers, doctors, all of these professions should get involved to try to see how this particular chemical affects all areas. And in that way, we'll be able to understand the use of this thing more. Now, melanin being so diverse, I can only cover a few subjects.
Okay.
And in covering these subjects, I'll only be able to skim the surface as far as information is concerned. But one of the key things that we like to bring out is that we're pushing the key to knowledge, the key to brain power, as one of the final physical properties or final properties that melanin offers the body, as well as this protective function. Okay, so we are looking at this thing, and it's showing properties that it's the key to memory, the key to knowledge, that sort of thing. We want to push that, as well as it offering physical assets, such as what you find in our athletes. And if you notice here, we have the chemical structure of a melanin. This is not the only melanin. This is a melanin.
How many are there?
That has not been defined.
Okay.
There are various types, and it's biochemists and chemists around the world now who are doing research on melanin. They are trying to elucidate the structure The actual structure is not known, but this is what is one of the structures that's sort of like used as a guideline. So when individuals look at this structure, they can get an idea of how complex this molecule is. But we're showing it here in the brain to let individuals know that it's saturated throughout the brain in major functional sites, major functional regions, as well as in organs throughout the entire body. And the skin being the one that's the most visible, we see it all the time, the eyes, the hair. Okay, that's what we've concentrated on the most. However, if you go into the body and use certain analytical techniques, you can actually see that there's melanin in various sites throughout the body, and key sites that have been identified as being highly functional areas. Then the question asks, why is it there? Why is it in major areas in the body? You see? And so these are the things that scientists are asking today, and these are the things that has been researched in the last 20 years, because this thing has just really gained momentum. Even though we have information, and you can search chemical abstracts, you can go back to biological abstracts, you can search lots of the cumulative index in the medical journals, and you'll find that there's a host of information, even back to like 1907, around the turn of the century. But in the last 20, 25 years, and right after World War II, there were several international conferences to study this particular chemical. Now, I call it a chemical. Other people refers to it as a hormone. Some refers to it as a polymer. But basically, it's a polymer, just like plastic. If you think of plastic, if you think of the polyester that you find in the body of a Corvette, well, that's a plastic. But it's a different type for a different function. The polyethylene that you use as trash bags and for various other things in your household, that's a polymer. And polymers are made up of various units depending on what the scientists want for the end product to do. So we'll talk about this thing relative to a chemical and physical aspect. And we want you to think that, we want you to know that without melanin in the brain and in all of those functional regions, then you don't perform, those areas don't perform like they should.
Okay.
Again, this is the product here. One of the things I like to point out here, if you look at the many ring system, and what I'm calling a ring is the cyclic, the circles. And you also see there's straight chain systems here with unsaturation in it. The unsaturation, double bonds as we call it, are pointing to areas that like to react. These are areas that an organic chemist will look at and say, okay, what are we going to do with that chemistry there? Well, if it's an amine there, if it's a carboxylic acid group, if it's a double bond, if it's a triple bond, if it happens to be aliphatic, if it happens to be aromatic, those things tell the chemist what this molecule will do or what can be done with it.
Okay, but looking at that,
and looking at this particular system here, you see hydroxyl group, you see carboxylic acid groups, and amine groups, aromatic rings, aliphatic straight chains, and you say, my God, this product can undergo many reactions at once. Melanin can undergo many reactions at once. Now, what does that mean? Now, can you think of the magnitude of a product or melanin being able to undergo, say, an oxidation-reduction reaction, or oxidation reaction on this side, and over here, on the other side of the same structure, a reduction reaction is going on. Okay, these oxidation-reduction reactions is just various types of reaction, or two types of reaction that goes on, pretty common in organic chemistry. But you don't find an awful lot of molecules that are able to do this. Now, when this happens, what happens? Well, this translates into many chemical and physical changes that product is undergoing or making other products around it undergo. So that, in turn, will make you do many different things. It also can be associated to the multi-rhythmatic nature of black people. The ability of this molecule to undergo many different reactions at once, rhythm, that sort of thing. That means we'll process that information real fast and kick out a response. Now, if you're talking about processing information, kicking out response, you're talking about a high-tech device. This high-tech device is like a huge computer that's taking care of everything it's supposed to take care of. And it's doing it with many, many functional groups. If it didn't have all of those functional groups, then it wouldn't be able to do all those reactions. Now, this particular one here, again, we're using it just to show that it's a standard. You can just say, hey, this is a melanin, but melanin can be a homopolymer of tyrosine, the homopolymer being that if this is tyrosine and tyrosine looks like this finger here, then all of these fingers that look alike will link up and make a melanin, and everything in that polymer will look like that finger. Or it might decide to put in several different types or several different species in that melanin. And when it put this one, the thumb, and several other species in it, then you come up with a melanin of a different character. And that's what nature did. Nature did not make the same type of melanins to go in the same in a particular area
of the body.
The skin may have a melanin that's made up of all tyrosine. There's an area in the brain called the substantia nigra. They are theorizing that the melanin that makes it up is made up of all tyrosine. There's other areas like the locus coeruleus. They think that it may be made up of catecholamines like adrenaline, noradrenaline, things of that sort. So as we learn more and more about the structure of this thing, then we are able to understand what it does in the body and how it protects the individual. Okay, now these are known properties of melanin, and I like to cover some of the known properties because it's very important that we do. They've been researching this thing, and it's very, very evasive. We have a lot of high-tech ways of analyzing things today. However, because of this molecule stability, because it's an evasive molecule, they haven't been able to find out an awful lot about it. But they do know some things, okay? Now, they've been able to go back and find that it's been around for like millions of years. It's an ancient molecule, and it's been here from the inception of life. You asked earlier, what is it composed of? Now, this is kind of a general statement here, but it's a heterogeneous polymer composed of varying amount of different aromatic rings, okay? And the primary ones can be tyrosine or tryptophan, okay? Now, with all of these functional groups there's one other thing that we have to take into account. We as a human, we as a being, are made up of various chemicals. And these chemicals translate themselves into polymers, catalysts, enzymes, hormones, and etc. All of these things are held together by certain bonds, okay? And we show here that melanin maintains ionic, covalent, and metallic bonding arrangement.
Are we going to have to ask you to define those things?
Well,
go ahead.
Those ionic is more like a charge, a plus charge on the battery. Okay. Covalent, again, it's a charge, but it's a different type charge. Metallic bonding means that it reacts with metals.
Okay.
It can actually pick up metals and hang on to them. There are other bonds that, because of the structure of the molecule, like hydrogen bonded, van der Waals forces, okay, those are not listed, but just from looking at the structure, it has to take place because of the way the molecule is made up and the functional groups are there.
Okay, but your point is?
The point is, ionic, covalent, and metallic bonding arrangement plus hydrogen bonding plus van der Waals forces in one particular chemical, that's highly unusual.
Okay.
So that translates into many, many, many more chemical reactions that can take place, in addition to all of the other functional groups that are there. So now this thing starts to build itself up into a bigger computer, if you will. Something that's multifunctional. I can do many things. Just expose it to me.
Okay.
Okay. Another thing too is if you go and research the primates, and you dissect them. As you go up the phylogenetic ladder, and as you get closer to man, you find that there are areas in the body that become blacker, or becomes concentrated with melanin, and it reaches its peak concentration in man. Okay? Now,
let me ask you this. Everybody has some level of melanin.
Exactly.
In the body.
Everyone has a certain amount of melanin in various areas in the body. Mm-hmm. However, it tends to be found in higher concentrations in the body of the black man, and in centers.
And woman.
Black man and black woman, yes.
Okay. Go ahead. Go ahead. Go ahead.
And more centers in the body. And if you want to look at that, what does that translate into? Okay. The centers, again, having major functional properties. They have to work. It has to do things to make sure life is good and life is essential. Life will last. So melanin being in higher concentration in these areas ensures that the proper reactions are taking place, and not just the proper reactions, but the proper amount being there will cause the proper reactions to take place. However, if a certain area of the body needs a certain concentration, say of 50%, or just for lay terms, say in order for a chemical reaction to take place in the eye, mm-hmm. you need 50% tyrosinase. Now that's not practical, no, but I'm just using that as a term. Okay, well what if you only have 45 or 25% tyrosinase or melanin? Then that reaction will not take place, even though you have some there. Mm-hmm. So concentration is very, very important in any scientific experiment.
So in this case, the concentration of melanin is very important.
It's very important.
Okay, I don't want to take you too far off your...
Well, think about it. All right, right. If you receive a high dose, a high concentration of X-rays, what does it do? It's very detrimental. If you put a high concentration of sugar in water, it becomes very sweet. Mm-hmm. So when you're actually doing chemical reactions in the lab, you actually have to weigh out the ingredients to make sure that they're in the proper ratio so the reaction will go. Okay? Now, melanin exhibits extreme stability inside and outside the body. And that's been one of the things that have kept scientists from being able to do what they want to with this thing. I mean, if you find it, 2 or 3 million years, you can go back and find melanin. When you dig up bones, and you find melanin that's there, still active. Okay? Why did it not degrade? Why is it still there?
This is after thousands of years.
After millions of years.
Uh-huh.
Okay? So, it being stable prevents it from being analyzed, because you can take all of the known techniques and try to analyze this thing, and you can't do it. First of all, they don't know what the structure is, and if you don't know what something is, how can you set up a systematic route for trying to track it down? So it's a trial and error thing, and most of the literature that's generated today is trying to fingerprint things, and they're doing the best that they can, but you know, they're hitting and missing. Mm-hmm. and finally coming up with something 5-10 years later after they hit and miss.
Okay.
But this extreme stability tends to get in the way of analyzing this thing. Now, melanin exhibits extraordinary binding properties for aromatic and lipid-soluble compounds.
Let me ask you to go back there for a second. In terms of breaking melanin down, how is that done in the laboratory today? And how easy is it?
It's not real easy.
Uh-huh.
It's not easy at all. Most of the time, if I wanted to take iron, calcium, manganese, any metal, or any organic system that's kind of hard to dissolve, you come up some acids and some bases, strong acids, strong bases, put them in solution, and they eventually get in. Mm-hmm. With melanin, you use strong acids and strong bases, but it's more difficult. The ability to dissolve this product is extremely difficult.
Okay.
And therefore, they have to look for either very, very concentrated systems or systems that they normally don't use that are very, very corrosive that can get it into solution.
Okay. Fine.
Okay, melanin exhibits extraordinary binding properties to aromatic and lipid-soluble compounds. This is very, very important here because...
And your mama's asking you, what does that mean?
Okay.
Go ahead.
Aromatic compounds are things that have benzene as the structure. And we know benzene as one of the components that we burn in our car, gasoline. Okay, and we call it aromatic. Okay. Lipid-soluble, lipid is just fat. Okay? Now, it binds to fat-soluble compound, it binds to aromatic compound.
Melanin binds to, go ahead.
Right. Or these compounds will bind to melanin. Okay? Now, this can be helpful or it can be toxic. And we'll get to that later on in the show where we talks about the harmful effects of toxic drugs on these black centers in your body. Toxic drugs like cocaine, LSD, and marijuana.
Okay.
Okay. Melanin continuously produces functional active free radicals for initiating electrical charges in the body, and these changes causes certain chemical reactions to take place. Now, we told you earlier that it actually absorbs free radicals. It neutralizes free radicals, and that's this number two.
Free radicals being?
Free radicals, again, being that charged particle that we talked about earlier that's trying to search out something to react with. So it can...
Free radicals, okay.
Right, so it can become neutral. Okay? Now, melanin existing in your body now keeps a stable free radical inside its structure. And that's consistent in all of the studies that they use to look for what they call electron spin resonance.
Can I say that again? I want to ask you another question.
Electron spin resonance. It has a stable free radical within the structure of melanin all the time. So, we talk about harmful free radicals degrading the body, but why does melanin keep a free radical within itself, and yet it doesn't hurt the body?
And welcome to the second part of our series on melanin with Mr. Carroll Barnes, a melanin researcher who for the last 14 years has been a polymer or plastic and rubber researcher in the chemical industry. We begin this segment by discussing melanin's sensitivity to changes in the Earth's magnetic field, radar, electromagnetic radiation, sound, and electrical stimulation.
Melanin has semiconducting properties and responds to light, sound, and electrical stimulation. Even the Earth magnetic field. If the Earth magnetic field changes and you're walking down the street, the melanin in your body, the electrons, the double bonds, causes it, this magnetic change will cause that structure to flip around. It feels the changes in the Earth magnetic field. It also feels radar. It feels electromagnetic radiation. It feels light. It feels music. So anytime you got an energy wave that comes in contact with this molecule, it is a highly efficient molecule. This efficiency translate, or this absorbing power of melanin translate into efficiency, which translate into the compound appearing black. If it wasn't efficient, then some of the energy would be repelled and re-radiated away from the molecule, and you would not have the black color. But you have the black color because it's a very, very efficient molecule. I want to talk about the sound here.
Okay.
High bass sound. I shouldn't say high bass, but heavy bass, which translates into our culture quite a bit.
African culture.
The African culture. Is stimulating to this particular molecule. Okay? High sounds tend not to be stimulated. And if you think in terms of nature being efficient, you would think, now, why would you create something that would have to absorb high energy unless it's going to be around that? Okay? You want to be able to absorb energy with the least amount of effort. So that means if you move your feet, the low sound that's made has to be absorbed. The bass is a low energy sound.
Okay, and this matches with melanin because of what now? If I'm not picking you up right.
It matches with melanin in the fact that it can pick up these sounds. Okay, by the mere fact that I know we can pick up low bass sound, this particular molecule can pick up low bass sound, then I translate that into the cultural things that we're doing. Okay. And that translates into common sense. Common sense being, why not be able to use every sound that's made, no matter how faint or how low? You see? So
we know we're making it very difficult for you because we know that you're a very technical person and you got a very technical field here. So just bear with us, and you're doing fine. But go ahead. but I see you groping there, and I want to explain why you're groping. Okay. Go ahead. Go ahead.
Sound is very, very important. Okay, and we found that there are areas in the body where light and sound does not come in contact with, but yet are highly black, highly pigmented with melanin. And therefore, we're saying that, well, there's some other function that melanin serves other than protecting your skin from sunlight. And this is why I was trying to explain about the sound, the acoustic thing, and the electrical stimulation.
No, give me the high bass thing again. I want the high bass this time, and melanin, and how melanin reacts to high bass.
Okay. There's levels of energy in every molecule. And we look at it, we call them double bonds, we call them triple bonds sometimes. And the physicists, when you get into that area of things, you can call electromagnetic radiation rotational and vibrational energy. And it's just like different levels, different orbitals. And some of these levels or some of these orbitals tend to pick up energy easier than other orbitals. So if you have 4 different orbitals, the easiest one to get energy into may be this one. The second easiest one will be this one. So when this energy comes in here, that's the low sounding bass. And then if you increase the energy input, this energy that came in from the low sounding bass will be kicked up to the next level, and this will be kicked up to the next level and to the next level. I'm saying that if you're an efficient system, you got to have sites that are on the lower end that will pick up energy and use it, and that's what melanin does at the bottom of the energy spectrum, the lower energy levels. It will pick that up, and then if it has to, it will pick up the very high energy levels, which may come into play when you're at the equator and you got cosmic energy bombarding you all day long.
So this is a chemical. This is a chemical thing manifested culturally,
right?
In Africans and African Americans.
Exactly. It's sort of like built into your genetic code that certain things you do relative to the things you create in your culture is based on your body chemistry. And it's just like the final product. Almost everything we produce is based on the chemistry. Plastic, drugs, almost anything out there in this supposedly highly technical world that we have here, anything that we produce so far is translated out of our genetic makeup into the chemicals that we have to work with around us.
Okay, if you say melanin is a polymer, which is plastic-like, what does that have to say about the black skin and its texture?
I think that if I would have to predict, I would think that melanin being a polymer that's rings stacked on rings, it will be a rigid, tough system, very tough, okay? Just from looking at that structure, that's the first thing as a scientist I would say, because normally if you're going to make high-performing polymers out in the workplace,
or plastics,
out in the workplace, they get away from the straight aliphatic chains that are kind of weak, and they build strong systems from aromatic systems, just like you see the structure of melanin there. It's a ring system. If you put those ring systems together, it's rigid and you can't move it. You see, it's tough. So I would say that it, as a physical aspect, it will make the skin tougher. Okay? From a reactive aspect, then you start talking about all of the other functional groups on that.
Okay, well, what are the implications for this in terms of radiation and the toughness of that skin? Is there, do we need more radiation? What, because of the toughness? I know this is stretching you, but go ahead. You may not know the answer.
Well, well, when you say toughness, you're talking about the physical aspect of something, the physical.
All right.
Okay? But just because it's tough and it's black does not mean that when radiation hit that particular molecule, there isn't functional groups there that it can react with. So
well, you know, you've heard people say that black people need more radiation.
Need more X-rays in order to be able to. Yeah, I understand what you're saying, but no. If you just want to take an X-ray of someone, give them the same amount of X-ray. However, because it's a high energy molecule, it will pick up some of that energy and to localize it through resonance throughout its molecule, throughout its structure. So there is some truth to that, but not enough where you would have to just overdose someone just to get the radiation through the melanin.
Right, just let them stay there for about 2 hours.
Okay, and that, again, that translates into the toxic part of this thing. We need to talk about the protective and the toxic role.
Okay, but let's not get to that. Let's stay on
of melanin.
Okay, let's stay on track. And
okay.
And
then I say a few other things here where it's synthesized there in the leukocytes, some, various sites in the body, and it's transported by the bloodstream sometimes. And being transported by the bloodstream, that means that every cell throughout the entire body have access to melanin all the time. Now, we're going to go through these pretty fast here. We talk about it's an amorphous semiconductor, and it may regulate neuronal firing. Well, a lot of the precursors to melanin are neurotransmitters. Okay. So here we have a huge neurotransmitter, you see? Okay. Something that has all of the power of the smaller neurotransmitters.
Such as? I'm not clear.
Neurotransmitter like norepinephrine, dopamine.
Oh, that really clears it up.
Tyrosine.
That really clears it up.
Messages are transmitted throughout the body by electrical signals and chemicals. Chemicals are very, very efficient transmitters of information, just like a computer. Well, nature decided to do it with organic compounds. Well, neurotransmitters just transmit an electrical piece of information or a chemical piece of information from one molecule to another molecule throughout the body, so things can happen.
Okay.
You wouldn't be able to shake hands, bow your head, do many different things unless those neurotransmitters was sending information back to the brain to process all of the environment, all of the things that's happening in your environment.
Okay, now, give me this first one again.
Okay, it's an amorphous semiconductor, and
Which means an amorphous semiconductor.
Okay. Amorphous in nature means that it doesn't have a true crystalline form, like, say, table salt. Table salt is going to be square planar all the time when you put sodium and chlorine together. But this, and then you find other polymers like polyethylene may have quite a bit of crystallinity in it, hard structure, it actually taking a form. Whereas amorphous means that it doesn't really have a form.
Melanin.
Right. It's ever-changing. It changes all the time, so it really isn't crystalline. They haven't established it as being a crystalline polymer yet. It's more amorphous.
Okay, go ahead.
and it may regulate neural firing. So there's beginning to generate some information that might point in that direction. It may function as an organic superconductor at room temperature. Now, this is something that's almost unheard of. Most of your superconductors are not organic. They're inorganic. And then you don't conduct electricity at room temperature. Superconduction in these inorganic systems are done when it's very, very cold.
Give me examples of what you're talking about.
Minus 400 and some degrees K.
Okay.
You have to get down very, very low in temperature in order for electrons to travel through a metal object, copper or whatever superconductor they use. And in order for it to flow, superconduction begin to flow with no resistance. So in order for electricity to flow through an electrical cord with no resistance, that's superconducting.
All right, clear.
Okay? Now, it's done at very low temperatures. You can't do it at room temperature. And what's fascinating is that melanin appears to be able to do it at room temperature.
The significance of that being?
The ability to transmit information almost at will. I mean, at no resistance. You know, if you got some information here in your brain or something happens down here, well, it's there before you can even think about it. Okay. That information has been processed and sent here.
Okay.
So with no resistance of that electrical information being sent to the brain to be processed, in other words, it goes there really fast with no resistance, which may translate into the quickness of the black athlete.
Now, you said melanin is able to process information without sending it to the brain also, right? Would you explain that? Is that true? Or?
Now, melanin having all of these functional groups. Remember, we talked about amine, carboxylic acid, ether, aromatic rings, double bonds, all of these functional groups. And all basically you're looking at is an information processor. Now, why in the world should I have to send information to you if I got all of the artillery right here to take care of that? So if I cut you on the leg, my melanin is not going to send the information to the brain and say, okay, tell me what to do down here. I've just been cut on the leg. It just goes ahead and starts directing all of the cells or the white blood cells or whatever to rush to that site, and it start responding. It start responding by telling everything what to do in that area because it's got all of the necessary pieces right there.
Without reporting to the government.
Without reporting to the government. Exactly. So this is in itself, it behaving as a brain. So the brain is not just in your skull or up here, but the brain is your entire body. Okay? With many computers dispersed throughout. And the master brain being the 12 black centers in the brain, or many black centers in the brain, that handles and constantly monitors the entire process.
With all this that you've said, and you got much more to say, I know, because we haven't even started yet. How do you see this information in light of the put down of the black skin?
How do I see it? I see this information as being very, very, what we call state-of-the-art high-tech. And all of the information that black people have received about, or constantly received, about the defective nature of being black or having black skin is completely opposite. The opposite is true. The black skin is black because it has that chemical there, but that chemical actually is a very, very high-tech chemical that is working very, very efficiently in that area to take care of all of the necessary duties that's required.
And you like to caution us once again that that while most of us see melanin and think of melanin in terms of the skin, that's just one small part of it.
Right.
But it has some mental
It has
functioning.
It has many, many mental functions.
Okay, we're going to run along. Go ahead.
Okay. If we go to the last one down there, it may play both a cytoprotective and cytotoxic role, okay, through its free radicals, or the absorbing of any energy. And the protective role, again, is protecting you, keeping you healthy, and enabling you to live for, say, like 120 years instead of living 60. Cytotoxic being that if you're not good to this thing, then it can't do much for you.
Okay, give me an example of the first one, cytoprotective.
Protective, okay? As soon as if you cut yourself, melanin rushes to that site and start the healing process. It may depolymerize itself to produce smaller chemical units that may have bactericide properties. It's sort of like putting on something that will kill all of the bacteria there. Well, you already got one built in. When melanin rushes to that site, it knows to do that. And you've noticed that after you've healed, you will notice that that area around the wound is very dark, which meant that melanin ran and accumulated at that site because it had some work to do.
Oh, they've been running quite a bit on me. Go ahead.
The toxic role is, the cytotoxic thing is this. We have to be careful about the poisons that we come in contact with, whether it's through the air, through industrial areas that we live in, the sides of town where all of the dumps are. We have to be careful with the drugs that is administered to us, even legal drugs like the neuroleptics. We have to be careful about...
You say neuroleptics, what do you...
Those are the phenothiazines, which are the tranquilizers that they use to treat mental patients.
Okay.
There are certain other legal drugs that are similar to melanin in structure or have some aromaticity about themselves that they will actually dissolve into the structure of melanin and kick melanin into another state that it doesn't like to be in. And when it goes to that state, it's not melanin anymore. It's a hybrid. It's something in between. It may have a certain charge on it that that particular area of the body don't like. So that particular area may go and produce cancer. It may produce a skin rash. It may cause you to become depressed. It depends on the part of the body that goes out of order.
Okay.
Toxic drugs like cocaine, LSD, all of those things are very, very toxic to black sinners.
Did I understand you to say earlier that melanin has an alkaloid base?
It's an alkaloid.
It's an alkaloid.
Right, there are many alkaloids.
Okay, and cocaine?
Cocaine is an alkaloid. There are several chemicals in the body that are natural for us that are alkaloids, and that's in the portion of the presentation.
Oh, go ahead. Oh, go ahead. Well,
okay, it's further on down the line.
Okay.
Now, on the last, where it may reproduce itself, this is a hypothetical situation here where they are thinking that melanin controlling various enzymatic functions in the body, it itself might actually take up a role, sensing that it is needed somewhere in complex with other cations to make an enzyme that the body may be deficient on. When this enzyme of melanin may actually kick off the other things that will make more melanin. So that's what we mean by may reproduce itself. This is an early stage of investigation.
Okay.
Also, you have to think of melanin, okay? Melanin really is a black amine, because if you take the word melanin and break it down, mel is a Greek word which means black. It comes from the Greek word melano, which means black. Okay, melamine means it's a black amine. Okay, a black amine. Amine is a hydrocarbon, aromatic, or well, we'll put it this way: an amine is any aromatic or cyclic system that has a nitrogen functionality on it.
Okay.
And we find that melanin is of that nature.
Okay, may reproduce itself. How? Melanin. How does melanin reproduce itself?
Well, as I said earlier, it may sense in the body that it needs more melanin in a particular site. But tyrosinase, which is the catalyst that actually polymerizes a great many of the precursors to melanin, may be low in a particular area. Well, it may sense that and go out and complex with the copper itself and make a species that can be considered a catalyst that will go out and react with those precursors and make more melanin.
Okay.
Okay.
Can a
Now this is a potential of melanin.
Oh, okay.
This is not a confirmed.
Okay.
In fact, this is one of those things where the scientists look at the structure and they've looked at various other things that are going on in the body, and they say, well, if this happens and that happens, then maybe this will happen.
Can you use melanin to, or use diet to boost the level of melanin in your body?
You can.
How?
Not necessarily diet, but you can. Well, you can get radiation from the sun. You can go out in the sun and lay out in the sun. You can increase your melanin content in your.
Yeah, go ahead. I don't know if you want to do that too tough. Go ahead.
But that's good for you. Even the darkest skinned black person is supposed to get out in the sun and sunbathe. Okay. If you want to get it through foods, you can't just take melanin as a. Remember, it's a very, very stable system, and you can't just take melanin capsules or something like that.
Right.
You get melanin in your body through foods such as bananas, eggplants, things that are high in content of dopamine, L-dopa. And this L-dopa, once it gets into the small intestine and you go across the small intestine into the bloodstream, then this L-dopa will polymerize into melanin because it will come in contact with the catalyst that will cause the polymerization to take place, or the linking up of these precursors.
Why would a person want more melanin in the body?
That's a good question. I think genetically we have those things already. You can increase the level to a certain point, but I feel that if you eat things like dopamine that are high in content of dopamine, then that dopamine will be used in the body for other things.
Okay, go ahead.
Okay. In addition to, say, like bananas and eggplants, most of your citrus fruits, cabbage greens, that sort of thing, have high concentration of dopa in it. Now, we talked about the skin. You know, it's the huge organ, and everybody look at the skin and, wow, it's black, you know, and that's where most of the melanin is, but that's not the case. I mean, look here. If you look at the major locations within the human where melanin has been deposited or is there all the time, you see that the skin and the eyes and the hair.
What does it do in the eyes? I'm going to walk you through this.
Okay.
What does it do in the eye? What does melanin do in the eye?
Okay. As you review all of these areas that we have up here, you're going to see that this black layer is always laid over regions, systems that have to go through major functional processes in order to support life. In the eye, before light, see, light goes through the eye, and it's processed and changed to a chemical signal and finally reaches the brain, and then we react. Okay, we see things. But before it gets to the rods and cones, over the rods and cones is melanin. And the light comes through the eye. It has to go through melanin before it gets to the rods and cones, and then further carried on through the brain. Okay? So it enables you to see a more vivid hue. If you see red, if you see blue, if you see green, the hue is sharper, and it's louder. So that translates into the things we are associated with.
Somebody told me brighter.
Brighter. That's it. Brighter colors. That's it, man.
I said louder several years ago, and they said brighter.
Brighter colors.
I like that, yeah.
And when we see those colors, then we tend to display those colors in all of the things around our society, because we're actually seeing a true picture of what's there. And all you're seeing is reflected light anyway.
Okay.
Now, melanin being a light absorber, it's going to absorb all of the colors of light in the inside, and anything that's reflected out, just like your tie, my tie, you know, all we're seeing is red light. And this is what happens when there's a reduced amount of melanin in the skin or in other organs throughout the body. Now, this happens externally. We see this all the time. But what we don't translate is that in all of those regions internally where there is no melanin or low concentrations of melanin, that same thing is happening.
People, in this evening's program, we'll revisit a conversation with the late James Baldwin. But first, we continue our series on melanin with Mr. Carroll Barnes by discussing melanin's anti-aging properties.
And this is what happens when there's a reduced amount of melanin in the skin or in other organs throughout the body. Now, this happens externally. We see this all the time. But what we don't translate is that in all of those regions internally where there is no melanin or low concentrations of melanin, that same thing is happening. So we as humans cannot function like we as humans tend to go down in functionality. The things that those particular organs are supposed to do cannot do it as long or as well, and the ability to perform goes down as you remove concentrations of this melanin out of the system. And you see things like that happen. Now, if you go into the heart, the lungs, the liver, your sexual organs, things like that, if they are going through the same sort of aging process without that melanin being there, then that's detrimental.
Okay, now chemically speaking, why does the black skin seem to not age as fast as the white skin? What is happening where melanin is concerned?
Okay, internally, I can explain it in two ways. Internally, there are some things that are going on, and externally, there are some things that are going on. Internally, there are lots of free radicals that are produced, or charged particles, as a result of regular body metabolism. And the body has to have a way to get rid of that excess energy or this runaway energy. And if it's not gotten rid of, then it will tear up all those other systems that it is around. Externally, we got radiation from the sun, electromagnetic radiation from computers, radar, microwave, all of this high-tech type of energy that is coming in contact with us, as well as natural energy. Now, this energy attacked the proteins, and it just so happened that the protein, being a polyamino acid, has a nitrogen group in it that loves to absorb around, say, 260. Now, if you don't have anything there to protect that protein from that UV light that's coming in and that's going to absorb that 260, then that protein is just going to split up and break down back into the small components that it was made. Therefore, you get cancer, lots of other diseases started, you know, deterioration of the brain, some things like Alzheimer's disease and that sort of thing. The protection that melanin provides is it actually captures that energy, neutralizes it. It neutralizes that energy, and it either holds it so it won't hurt the body, or it uses that energy in a practical manner in the body. See, it doesn't say, okay, I'm going to catch this energy and I'm going to throw it away. It's trained itself to think further. Say, what am I going to use this energy for?
Efficiency.
Right, efficiency. So the efficiency of the molecule comes out.
Okay, we got about 15 more minutes. Go ahead.
Sounds good. Now here, you know, right after conception, if you look at the human fetus, you got three layers that's, you know, most people know about: the endoderm, the mesoderm, and the ectoderm. Now in the ectoderm, they've actually detected the melanin in the outer layer of the ectoderm in the developing fetus.
All human fetus.
In the human fetus.
Right.
Right. And there is some indication, but it hasn't been really proven yet, there's some indication that if that melanin is not there, then it may contribute to the baby aborting at some period in time. It makes sense. If you don't have a battery to energize your car, what is going to run it? Melanin, with its ability to produce and direct electrical currents, it's theorized that this is what it's doing. It's directing the electrical current to the DNA, the RNA, all of the raw proteins, and telling them how to link up. Okay. Now, if you don't have that electrical current, just like in any piece of equipment you have around here, if you don't have a current to tell that thing to run, then it's not going to run.
Okay. Let me rush you along. Go ahead. Okay.
Okay. Then I want to show here that this black layer, this ectoderm, actually become the thing that actually controls you all your life, your central nervous system. The early you see the ectoderm goes through an early stage of development, it encapsulates and it finally becomes the brain and spinal cord.
Okay, now say that again.
This black layer, which is the ectoderm, actually invaginates as the developing fetus grows. And that black layer actually become the brain and spinal cord.
Okay.
So you can say that the system that controls you, or that controls the body, actually came from a melanated layer of cells, the ectoderm.
Okay.
Now, why is that important? That's a very good question. So it's got to be important if your central nervous system is developed from that black area. That's all I'm saying.
Okay.
Okay? Then you go back and say, okay, if melanin is this good, it's got to be a solution to a lot of things. And they are thinking that mental instability, if lack of that causes mental instability, the schizophrenia, maniac depression type of things that you see in a lot of the psychotic cases, the tendency to commit suicide. What makes you depressed? All of these neurotransmitters that is tied up in the melanin structure have properties to keep you motivated. And melanin is a huge neurotransmitter, so it's going to definitely keep you motivated. You're not going to want to kill yourself.
What is the advantage you have being able to look at human beings chemically, from a chemical viewpoint? How you like that one?
Well, when I was in college, I used to do that, and I was thinking of human beings. You know, you just think about all the chemical reactions that take place. But when you look at individuals from a chemical viewpoint and you understand that what happens on the molecular level actually comes out and translate on the surface level. The things that you do culturally and socially is actually representing what's going on inside, even to the point of the way your body is designed. Your body is designed based on nature trying to say, okay, well, we got to make some more complex systems here to do the work that we want done. So what are we going to do? We're going to use that straight chain polymer? A million years from now, that straight chain polymer is not going to hold up. So what you do is you hang a polymer off of it, and you call it branching. This branching gives you a more rigid or more complex system. And once all of these things are done, it translates into surface things in the final product. Every product that you make has surface qualities, physical, tangible things that you can see in the properties of that product that says the lower chemistry, the chemistry of on the molecular level that makes this product up actually translate into what that final product is on the surface. And that's the same thing you look at in human beings. You have to look at why people behave and act and do the things that they do. And your body design and your body mentality, the things you do, all that translate into the whole chemical thing. I think if you really looked at the literature too, you find that biochemists, pharmacologists, and things like that, they're thinking that way.
You had a period in this country known as the minstrels era, where whites would blacken up their face to poke fun at blacks. Do you think that they were aware of the qualities of melanin?
I would think that that's probably the case. I think that they probably was aware of the qualities of melanin to a certain point. But then there's a whole psychological game that's being played.
Mm-hmm.
Deep in the genetic structure is the memory of the fact that they used to be black.
Mm-hmm.
And therefore, try as they may to get away from it, their genetic structure will tell them to do things that are black, or try to be, or try to acquire this medicine that used to keep you well and in good health. And that's the same thing that happens when you see them go out and tan. It's the same thing as the menstrual thing you're talking about here. They're trying to acquire this chemical that actually translate into good health.
Okay, we got 3 minutes left.
Let's see what happens, okay?
Let's see what your reaction time is like.
We talked here about it being an extremely stable molecule and why it's been neglected. We won't deal with that because we know why it's been neglected. They can't really study the thing because of the stability of it. Also, one of the other things here is the general attitudes towards race. Even though you have scientists who are supposed to be highly intelligent scientists, there's a general attitude towards race and it being the primary pigment responsible for skin color, then there's no reason to study it, or it's just a waste product and, you know, it's not important. So you find that the information hasn't developed as what it should have been.
If there was one thing you could tell the world about melanin, what would it be? Your last opportunity.
I feel that melanin is the most complex, most perfect molecule in the human. And I feel that the thinking should be changed around on it, and we should not look at it as being a detrimental thing. It's a very, very positive thing.
Okay.
Whether it's in your skin or in your brain, it's very, very positive.
Melanin and mental abilities, 30 seconds.
Melanin is the key to all memory, key to all knowledge. And without that, then there would be no civilization, no rules, no morals. There would be no intelligence. And this particular chemical actually propelling the brain to do all of the thinking, to do all of the coming up with new knowledge. If it wasn't for that chemical, then knowledge would not exist.
So black, far from being an aberration, an abnormality.
It is far from that. It is the reason why we have civilization today. It is the reason why we have high brain power. It's the reason why we exist.
Thank you, sir.
Thank you.
How did you learn all of this stuff?
Oh, man, I'm just happy.